Hello, it's Mr. T here. So in this video, I just want to look at amines and carboxylic acids, and we want to just talk about the characteristic reactions of them that we need to know for level 2 NCA. So an amine, remember, is an organic molecule that has an NH2 group attached to the carbon chain. An example at the top here is the molecule 2-aminopentane or pentan-2-amine that we can also call it. Now, what an amine will do is it will dissociate with water. Because an amine is a weak base, it will undergo a reaction with water where it accepts a proton from water. So here we've got the amine at the bottom here. This is butan-1-amine, and the water is going to donate a proton to the butan-amine, and it's going to produce this ion at the end, or the functional group that's an NH3 plus functional group. At the same time, because the water has lost the hydrogen, it produces a hydroxide ion, which is the ion that we associate with bases, so it gives it the property of a base. In order for an amine to be detected as a base, it needs to be put with acid in the first, with water in the first instance. So the actual molecule we produce here, we don't need to remember the name of this functional group, but we would generally call it an alkyl ammonium ion. So if we want to test to see whether the sample we have is an amine, one of the tests, or the positive test for an amine, is to actually just put some damp red litmus paper and just put some amine on the damp red litmus paper. If it goes blue, that means it's a base, and the only group of organic compounds at level 2 that turn litmus paper blue are amines. So it's a definitive test for an amine. That is, we will use red litmus paper, damp red litmus paper, and it will turn blue. Okay, so amines, because they are a base, they will react with an acid in the same way that they reacted with water. So what's going to happen here is, here's an example of an acid, hydrochloric acid, and it's going to donate its proton to the amine functional group, and it's going to produce the NH3 plus functional group. Now, sometimes the combination of this molecule and the negative chloride ion is called the salt, and they will form an ionic compound because we have this positive and negative charge here. So that's amines. Those are the two types of reactions there: dissociation reaction and an acid-base reaction. The next type of compound I want to look at are carboxylic acids. We remember a carboxylic acid is characterized by the carbon double bond oxygen OH group at the end of the molecule, and this group is acidic. The hydrogen at the end here has a it wants to leave, so it has this ability, or this wanting to leave this molecule. So whenever it has an opportunity, it will donate to, let's say, to water. So here the hydrogen on this carboxylic acid functional group, this is from this pentanoic acid here, is going to be donated to the water molecule. And in this case, what it's going to produce is this ethanoate ion. Sorry, not ethanoate, carboxylate ion. In this case, this is pentanoate. So what's happening here is the hydrogen, the H plus is left, it's gone to the water to make an H3O plus, which is our characteristic acid ion, and it's produced this carboxylate ion. Now this could be at that stage tested with red litmus paper, and of course, blue litmus paper, and it would turn it red. Okay, so the other type of reaction carboxylic acids undergo is they can react with bases. So we can have a carboxylic acid reacting with a base. So we've got an acid plus base, and it's going to produce this salt plus water. Right, yeah, sorry for the interruption. So what we've got is we've got the acid reacting with the base here to produce what would be our salt plus water. So we've got the carboxylate ion and the sodium ion would come together to make, in this case, sodium butanoate, which would be our salt plus water. So this is an acid-base reaction or a neutralization reaction. We can also add specifically a carbonate, which is a base in itself, but this reaction here where sodium carbonate, or more commonly sodium hydrogen carbonate, is added to the carboxylic acid, and what we get is we produce the carboxylate ion or the butanoate ion here, the sodium ion, water plus carbon dioxide gas. Now this is a very important reaction because it is the carbon dioxide gas that bubbles and fizzes that is our definitive test, or the important test that we use to test for carboxylic acids. So if we add a solution of sodium bicarbonate or baking soda to our carboxylic acid and we get bubbles, we are confident that we have an acid, and that our unknown sample is a carboxylic acid. So that's a definitive test or a positive test for carboxylic acids. So I hope that's helped. We've gone over the different types of reactions for amines and carboxylic acids. That is the dissociation reactions they both have with water and the acid-base reactions. We've also looked at the types of tests that we do to determine whether an unknown solution is a carboxylic acid or an amine. I hope this has been helpful. If you want more help on organic chemistry level 2 NCEA, just have a look at my other videos. See you.